Power in some form or the other is a basic requirement for doing any work. A rocket needs fuel. We need food.
बायोप्लांट से आत्मा में भूकंप का खतरनाक हो सकता है और ये गोल
All electric or electronic equipment need electrical power. Some require AC power and the other DC power. Almost all electronic equipment and circuits need DC power only. Source of this DC supply are either batteries or the available AC power converted to DC form. Batteries are used only in situation where portability for outdoor purpose, continuity of supply, and quality of supply is of prime importance. In electronic laboratories and also in electronic industry, we require DC power for continuous operation, and if this power is to be supplied by a DC battery, we will need a giant storage battery, which even if is available will be very bulky and expensive. DC regulated power supplies which convert AC mains voltage to DC are therefore widely used in electronic laboratories and industry. So far, in this film we have seen that power in different forms is needed everywhere. Electrical and electronic equipment also need power. Most of these use more familiar types of electrical power, that is power from the AC mains or power available from the batteries. But in electronic laboratories or industries using electronic equipment, we use DC regulated power supply very widely. In the next part of the film to follow, we are going to examine only 4 aspects of DC regulated power supply. The functions of building blocks of a DC regulated power supply. Secondly, types of DC regulated power supplies. Then we shall analyze how to use a DC regulated power supply. In the next and last part of the film, we are going to examine few important specifications of a power supply. DC regulated power supply converts AC voltage to DC voltage using a transformer, rectifier, filter circuit and a regulator circuit. Transformer normally steps the voltage down. The rectifier converts the alternating voltage to unidirectional voltage. This unidirectional voltage is also known as pulsating DC. The pulsating DC is passed through a filter circuit which smooths out the variations or ripple. Filter can eliminate most of the ripple but not all. With a simple filter as is shown here, the ripple left in the final DC voltage can be considerable. A better filter is needed to minimize the ripple in the output DC voltage. Graphically, such a voltage can be represented by a straight line. In such a power supply, consisting of transformer, rectifier and filter only, variation in the mains voltage will vary the DC output level, which is not desirable. Similarly, output DC voltage changes if the load current changes, which is also not desirable. To avoid variations in the output voltage, a regulation device is necessary. The ability of a power supply to keep output voltage constant against fluctuation in input line voltage is called line regulation, and the power supply ability to keep the output voltage constant against variation in load current is known as load regulation. To protect the power supply from overloads and short circuits, electronic current limiters are included in the regulator circuit. Let us now summarize what we have seen so far. DC regulated power supplies are very useful in electronics laboratories and industries using electronic equipment. A DC regulated power supply converts AC mains voltage to regulated DC using a transformer, rectified filter and a regulator circuit. Transformer normally steps down the mains voltage. Rectifier converts AC voltage to unidirectional voltage. Filter removes pulsations. Regulator maintains constant output voltage. Let us now view the next part of the film, wherein you will see different types of DC regulated power supplies and use of DC regulated power supply. Different kinds of power supplies are used in electronic laboratories. There are many ways of classifying these. The classifications examined are based on device, based on metering, based on output, and special power supply. In order to utilize a power supply, it is necessary to connect the power supply to the AC mains. Switch it on. Often, a neon indicator is provided in the front panel to indicate whether the power supply is switched on or not. Adjust the output voltage to the required value using voltage adjustment knob. In some power supplies, the facility to limit the output current is available. The purpose of this is to save the power supply from accidental overload. By limiting the current to a preset value, not only the power supply but even the load device can be protected from the effects of excessive current. All power supplies do not have the same number of output terminals. Some have 2, others may have more terminals. In some power supplies, none of the output terminal is connected to the chassis or the ground. Such power supplies are known as floating power supplies. Here is a floating power supply. Since the output voltage has no reference to either the ground or the chassis, neither terminal of the output will indicate any voltage with respect to the chassis or the ground. Such power supplies are often interconnected to obtain a multiple output supply. Let us take an example. With two 15 volts floating power supplies, we can make 3 different power supplies. Let us see how we can obtain these voltages. Let us connect the common terminal as shown. If we measure the voltage between the common reference line and the positive line we get a plus 15 volt supply. If we need a negative 15 volt supply, connect as shown. Here is a plus minus 15 volt power supply. Keep the power supplies connected as before, but this time measure the voltage with respect to the lowest line. This means that the lowest line is now the common reference. With the change in common reference terminal, we can get a plus 15 volt supply or a plus 30 volt supply or both. Similarly, we can get a minus 15 volt supply or a minus 30 volt supply or both. In such interconnection, if we ground the common reference, we get voltage with respect to ground potential. We have just now seen how to interconnect floating power supplies to get a multiple output supply. We would now examine some other types of power supplies. Here is a valve type power supply capable of supplying multiple voltage. It has two HT supplies which can supply continuously variable voltage at a maximum current of 200 milliamperes. Another HT normally used to supply low current. The others are AC supplies meant for feeding valve heaters. Here is another power supply which provides a stabilized and unstabilized supply simultaneously. Linear ICs need positive and negative supply simultaneously. To ensure correct circuit operation, it is essential that even the slightest change in one supply must be offset by equal change in the other supply. Such power supplies are called tracking power supplies. When power at high current is required to be supplied at a fairly distant location, we use remote sensing power supply, which through sense terminals maintain the desired voltage at the load regardless of the drop that occurs in the connections. To use and maintain a power supply properly, here are few do's and don'ts. Unlike all electronic equipment, do not expose power supply to direct sun for long. Keep power supply away from dusty and humid atmosphere and also from excessive temperature. Ensure proper ventilation. Let the power supplies be away from your conversation. Avoid short circuit and overloading. Take care of polarities while connecting a power supply to external circuit. Before use, check the zero position of the voltage and current knobs. Apart from this, ensure proper earthing and use correct rating fuses in the power supply. This part of the film, we examined classifications of power supplies, use of power supply, output terminals on power supplies. Also, we examined how to use and maintain a power supply properly. If we want to buy a power supply, we would need to specify clearly what we are looking for. In the next and last part of the film, we are going to examine few important specifications of a power supply. Generally speaking, the characteristics of a power supply can be specified through parameters shown here. Output voltage, output current. Output current is often specified for a particular output voltage range. Load regulation, defined as percentage change in the output voltage from no load to full load. Lower the value, better is the power supply. Line regulation, capability of power supply to keep output voltage constant irrespective of change in input voltage within a specified range. Ripple, it is the measure of AC component in the output voltage. Finally, it is important to mention whether power supply is to be overload or short circuit protected or not. However, it is recommended that the power supply should be equipped with these protections.